When you think of something like, for instance, 1 plus 1, you know it's 2. Now what this means is that if ever you find 1 plus 1 in a mathematical sentence somewhere, you can replace it with 2. And the same goes for something like 1. For instance, if you have a 1 anyway, you can replace it, say, for instance, with 6 over 6. That's a technique where you can actually do a little bit of magic, manipulation of mathematical sentences or algebraic expressions in order to take out a common factor or to replace it with something that is more familiar or anything to that effect. Those are called identities. 1 plus 1 is equal to 2, and you can replace them alternatively wherever you find them. In trigonometry, we also have identities, and two of those identities are called fundamental identities. I'm going to look at them right now, but you just need to understand that the idea of identities in trigonometry is not so much to use those identities, although you are going to use the two fundamental identities. But the idea is to train your brain to prove that 1 plus 1 is equal to 2, so that you can use both of those cases whenever you find them. So all it is really is about finding a way in which to think so that you can take the left-hand side of the expression and manipulate it until it looks like the right-hand side. That's the bottom line of trigonometry, and specifically identities in trigonometry. So keep that in mind whenever you are working with these things. The first exercise that we are going to take a look at doesn't actually prove identities. You are just simply manipulating an expression. But when we get to the second part of this lesson, you will see that it actually just follows from one step to the next to now use that exact same skill to prove the specific identity that they give you. But now the two identities that they are referring to is that tan of whatever, let's call it theta. We like to use Greek symbols in trigonometry. Tan of theta is equal to the sine of theta over the cos of theta. That is one of the identities. This is called the quotient identity. And the other one is that sine squared of theta plus cos squared of theta is equal to 1. Now you are supposed to know how to get there. You are supposed to prove these two identities. And we will look at that in a separate lesson as well. How do you actually prove that tan is equal to sine over cos, and how do you prove that sine squared plus cos squared is equal to 1? For now, just bear in mind that those are the two fundamental identities. And when we take a look at the questions that they give us and they say, use fundamental identities to simplify or use fundamental identities to prove the identities, both of them use pretty much these two fundamental identities to get from one step to the next. Something that is just very important for you to understand before I conclude this introduction. The whole idea of working with trigonometric identities is similar to working with word sums. There is no set pattern, there's no recipe that I can tell you follow this and then that and then that and then that. You have to think your way through every single question that they give you. You must get to that point where you are actually thinking about what is going to be the next step. You will more often than not use these two techniques or these two identities to spot something. When you see a tan somewhere in an expression, go and change it to sine over cos and see where that takes you. But you also need to remember your normal algebraic skills. You need to remember your normal number skills, such as fractions. How do you add fractions? How do you divide fractions? Those type of things. You need to remember all those skills, but you need to think your way through every single question. There is no set recipe that you can follow and tick the boxes and say, okay, I've done this, and I've done this. Just bear that in mind as well.